Hey everyone, thank you so much for joining us today for our webinar on PostgreSQL Query Optimization. And this webinar will be conducted by my colleague Warda. By the end of the session, you will know how to troubleshoot performance issues and at the same time design scalable queries. So before I hand over the controls to Warda, I would like to go over a few housekeeping items. This webinar is being recorded and you will have the recording afterwards. If you have any questions, please feel free to use either the webinar chat or the Q&A feature in Zoom. So we will address them at the end of this session. That's it from my end, Verda. Over to you.
Thank you, Annie. Hi, everyone. My name is Warda. I'm a Postgres consultant at Stormatics. My background is a mix of software development and database internals. As a software developer, my focus have been on the backend engineering and mainly automation systems at my past organizations. For the past 1 year, I have been focused fully on Postgres performance, how to tune queries, how to tune performance overall, um, design and build high availability architectures, and also contribute to the Postgres community. So that's a bit of an introduction for me. And today we are going to talk about Postgres query optimization, specifically how to read, explain, analyze plans, and then how to use it actually to find and fix the performance problems. So, yeah, let's get started. So, here's the agenda. We'll start with the query pipeline. The four stages every SQL statement has to go through, and we'll zoom in on query planner and executor. From there, we will cover explain and explain analyze, what each one shows and which one to use when, and then we'll cover the keynotes. We'll also read and interpret execution plans step by step, and because keynotes are the building blocks of these explain plans, we'll also understand different type of scan and join nodes. um, and we'll also understand the performance bottlenecks, the common patterns to look for, and how to fix them. And then we'll close this session with a live demo where we'll try to fine tune a slow query. Yeah, so let's start with the Postgres query pipeline. Um, Before we even talk about optimization, we need to understand what actually happens when you tr- press enter on a SQL query. So every SQL statement goes through these four states. The first stage is parser. This is simply a syntax check. It just makes sure that the grammatical and syntactical syntax is correct for the query, and then and then it passes the output to rewriter. Rewriter is basically there to replace, if there's any view in the query, it will replace it with the underlying query, and also if there are any row level security policies implement it will um, inject those policies here. And these two processes are completely transparent. You won't be seeing them happen. They happen in the background. And then we have stage 3, the planner. This is also called as optimizer, and this is where the things get interesting. It takes the clean resolved query from the rewriter and try to understand what is the cheapest possible way to execute this query. And for this, it performs a number of steps that we'll discuss in detail going forward. And then it generates a plan and then forwards that plan to the executor. And the job of executor is to simply execute that plan. And for doing that, it will go to disk, read pages, evaluates the conditions, and then return the rows to the root node. The first two stages, these are because invisible. They are not really involved in our day-to-day work. We don't really care about them. um, they'll either succeed silently or will fail. But the last two, planner and executor, this is where we can step in and make some changes and optimize the queries. So we are going to focus on them. Okay, so let's talk about planner first. The job of planner is to simply ask, given a query, what is the easiest, cheapest possible way to return the correct result. um, Now there can be different ways a query can be executed. So and we'll understand how there can be different ways, but the job of optimizer is to generate all possible execution path or all possible strategies that can be used to generate the query result. And once it has all the strategies, it will estimate the cost of each strategy. And I want to emphasize on the word estimate here because the planner cannot run the query. It works entirely on statistics. It will just give you an estimate of how cheap this query is. And this estimate also comes from statistic that Postgres collects and store in a catalog table. So this is entirely an estimate, and then based on these estimate, it will choose the cheapest or the lowest estimated cost that it thinks it is the lowest estimated cost. It could be or could not be. It depends on the statistic that the Postgres has collected. So it depends, and we can only see that once we actually execute the query, that if the planner has chosen the correct path. um, and this is called as cost-based optimization, and Postgres has been doing this since version 7. um, but the key word in planner optimizer job is estimates. Everything that the planner does is based on estimates, and it matters because if the estimates are wrong, the plan choice that the plan that it has chosen, it can be wrong, and it will propagate to all the upper nodes and will slow down the entire query. So let's look at this query. We have customers joined to orders, and it is filtering on the APAC region. It is also grouped by name, and then we have order by clause as well. For each of the table in this query, so for customers table first, the planner will generate every possible access path, how to access this table. It can perform a sequential scan or an index scan or a bitmap heap scan. These are all different type of scans that Postgres can use to access a table from the heap. And similarly for orders as well, it will try to find out all possible ways to scan. And because we also have a join here on customers and order, and there can be different ways tables can be joined, nested loops, hash join, merge join. We will deep dive on these later. But these are all